What is up, everyone? Welcome to the 13th tutorial in our Pandas course. This is part 2 of this course, in which we'll be turning now to data frames. So in this section we'll just start by learning a couple techniques we can use to create Pandas data frames. For starters, we'll learn how to create data frames from Python lists, then from dictionaries, and then finally from other Pandas series. Now just a heads up, a lot of the stuff we're going to be covering in the second half will look a lot like the Pandas series functionality. And that's because data frames and series share a lot of the same functionality. Now of course data frames have a little bit more, and also there's multiple axes to deal with, so that's really where the variety is going to come in. Otherwise, let's head on over to Google Colab and get started. Alright, so last time we left off here. This was in section 12 where we covered our comparisons and iterations. It's just 12 comparisons and iterations. Okay, but that was of course all series related stuff. Now we're going to be working with data frames. We can go ahead and start up a new cell, and we're going to use again a lot of the same techniques that we've covered throughout. So basically a lot of this stuff will look the same through here and of course through here as well. Alright, so back down. We're going to first cover a couple techniques that when it comes to creating pandas data frames from just regular Python lists. Okay, so the first most straightforward way might be just to create one from just a basic list of numbers. Okay, so we're going to say df is going to be equal to pandas.dataframe, and we'll just pass in some values, maybe like 1, 2, and 3 or something. Okay, then we go ahead and just print out df there. Okay, so this is what it's going to look like. It does look actually a lot like a series with two big differences in the ways things are being displayed here. So first of all, note that it doesn't actually display the data type down at the bottom. And the other thing is that we now have this extra 0 up top. This is because we're now dealing with columns and rows rather than just columns or just rows. I guess when we're dealing with series, technically it's more like just rows. So all of the rows will have their corresponding indexes here, the index labels, but so will all of the columns. And if we don't explicitly assign them, it will label our indexes as just the positions of both the rows and the columns here. Now, much like a series, this will default to the data type of the data provided unless we assign a different data type. So I can do that when I'm creating the data frame by assigning a data type equal to whatever I want. Actually, while we're here, we may as well explore some of the other parameters. So you can see there's data equal to none. The data is going to be the main bulk of the values that we're going to be passing in. So again, this could be in the form of a list, series, or just like a dictionary or something. We can also pass in index and column labels, as well as a data type. Note how there's no name parameter like there was with the Pandas series. That's just because it's not quite as important with a data frame. Okay, so let's say we want maybe some NumPy float 16s or something. We could do np.float16 as the data type, okay, and that will explicitly assign the specific data type to the data frame. This time you can see that the values have all changed to accommodate for that float type. Also, if we do want to print out the type, I guess we may as well show that off our data frame. You should see that it is a Pandas data frame rather than just a series. Okay. Now, similar to before, we can have strings, or I guess in this case they would be considered objects, or true or false values. So let's just get rid of that. Let's create a data frame with a bunch of strings in it. So this will just be 1, 2, and then 3 like this. And we're actually not going to assign the data type this time because it doesn't really make much sense. We want to demonstrate the use of objects here. Okay, so it doesn't really appear to be very different, but these are indeed string objects rather than float 16s in this case. Okay, how about if we wanted true or false values? Well, we could do that. We'd say like false, true, false or something. Okay, and then we can assign true or false values as well. All the while, our index labels are still positional, and so are our column labels. Now, from here on out, for the most part, I'll still be working with numbers, just because I think it makes a bit more sense. I would say the majority of the data we deal with out there would be numbers, perhaps objects as well, but mostly numerical here. Now, the real reason for using a data frame is if we're dealing with multi-dimensional data. We absolutely can use a data frame for just one-dimensional lists and stuff. There's nothing technically wrong with that, but we may as well just use a pandas series because it's a bit more lightweight than a data frame. We really use a data frame if we have multiple rows and multiple columns. So for that, we can pass in a multi-dimensional list, and that will set up the data frame accordingly. So let's say, for example, we just wanted the numbers 1 through 9, but in 3 different lists. Okay, so we could do something like this: 1, 2, 3, 4, 5, 6, and then another list of 7, 8, and 9. Now, we can't enter it in like this because these are individual lists. We have to encompass them in an overarching list. Now we can go ahead and we can print that out. I'm not going to bother with the data type either. We can just get rid of that. Okay, so one interesting thing to note is how this is formatted. Now, when we enter in things like this, it's going to be setting up our rows, okay, 1, 2, and 3. Remember, you had 1, 2, and 3 like this, but now we are actually still following that format, but we're considering 1, 2, and 3 to be across columns here. Okay, and that's because each one of these is an element in the list, and now we're considering the entire list to be an entire element across a row. So if each of these is a row, that's just like saying each of these inner lists is itself a row, and then within them we have our appropriate columns, okay? So row 1, row 2, and row 3. So very important to know exactly how that's going to be structured. Also, we have now expanded our column indexes to 0, 1, and 2, again because we have 3 columns this time. If we enter in uneven columns, so this was a nice 3 by 3 matrix, but let's say we had something a bit different. Let's say we had a 4, maybe we only have 5 and 6, and then a 3. So we've got 4 items in this one, 2, and then 3. Okay, so this is still allowed. There's absolutely nothing wrong with this, but it's going to fill in the missing values with not a numbers. Because we said we have this one list with 4 columns, okay, 4 indexes, that means that the entire data frame has to take on 4 columns. So that means it has to fill in the missing values with something. In this case, it's just going to fill them in with not a numbers. Okay, so we've specified that we need 4 columns. So even the rows that have less than 4 columns need to have 4 columns. Okay, so it just fills them with not a numbers here. Also, equally as interesting, it has actually changed the data type of some of these columns, but not all of them. For example, columns 0 and 1 are still integers. Note how they are all whole numbers. However, columns 2 and 3 have been switched to decimal numbers, and that's because now we're filling in not a numbers, which we know are float types. So that means it converts the entire column into floats, but that doesn't mean it converts the entire row. Now, a lot of the operations that have to do with data frames are actually column related rather than row related. So if you see this kind of mix-up where something is affecting an entire column but not a row, that is actually the intended behavior. We can usually change that by switching up the axis, but more on that when we talk about the individual functionality. Alright, now one final thing I want to go over here is going to be assigning a single scalar value to multiple indexes in a data frame. So this is basically building up the shape of a data frame and then just populating it with a single scalar value. This could be a default value, maybe a bunch of zeros or not numbers, but is generally used to set up just the structure of a data frame. Don't worry, we will get to labeling of our columns and indexes, columns and rows rather, and also we'll talk about data frames with dictionaries, but that will be in the next section. Okay, so if we want to do that, all we need to do is specify what scalar value we want, and also specify the structure of our data frame by entering in column and row values. So let's say we wanted to create a data frame that is going to be 2 by 3. So we could do pandas.dataframe like so. Okay, we're going to just enter in a bunch of 5s maybe. And now we want a 2 by 3 structure. So that means 2 rows, 3 columns. We're going to pass in some index labels, and we're going to pass in some column labels. So because we want 2, we could do just like a 0 and 1. And because we want 3 columns, we could just do like a 0, 1, and 2 here. Okay, we can go ahead and then print out the data frame. As you can see, this sets up our data frame in this nice structure. Okay, so as long as we're providing index and column labels, that specifies the shape of our data frame, unless we have passed in explicitly shaped data. Otherwise, this is just going to populate this value across the shape into all of the indexes like below. Okay, so that's all I wanted to cover here. When we come back, we're going to be talking about some more creation techniques. Again, that'll be through using dictionaries where we can explicitly assign labels to our rows and columns. We'll also talk about how to set up list-like data frames, but also labeling the rows and indexes, rows and columns indexes rather. And then also finally, we'll talk about Pandas series and using those to build up data frames. Okay, that's it for now. Thanks for watching. See you guys in the next one. Hey everyone, welcome to the 14th tutorial in our Pandas course. Here we're going to continue on with creating Pandas data frames. Last time we focused mostly on creating them from Python lists. Here we'll just take a quick look at how to create rows and column indexes, and then we'll move on to dictionaries and Pandas series. So let's head on over to Google Colab and get started. Alright, so last time we finished off in section 13, again creating Pandas data frames with Python list and also just scalar values specifying the shape of our data frame and then using a single value to fill that out. So we'll get started with a new cell, and I just want to expand on this part a little bit first. And that is using different column and row labels. Now here we were just using numerical positional labels, so index 0, 1 and 2, etc. But if we want something a bit more interesting, we can totally do that as well. Let's say we wanted A and B to be our row labels, and then we wanted our column labels to be like col1, col2, and col3 or something like that. That's totally fine, and this is okay if we are just, I guess we should print that out, if we are just running or rather just using a scalar value. And that's because if we're just passing in a scalar value, we need to specify the row and column structure. And other than that, it doesn't really matter what labels we input here, as long as we're specifying that we need this number of rows and this number of columns. So this is really something that's unique to creating with scalar values. You need a row and column structure. If you are just passing in lists, you don't necessarily need to label your rows and columns, but you can do so just for ease of read. For example, let's say I wanted to create a Pandas data frame just from a list again. We're just going to do 1, 2, and 3 here, but I wanted to pass in some explicit row labels. One thing we need to make sure we're doing is making sure that we have enough enough labels here for each of the data points. So this is an array of 3, or rather a list of 3 elements, so we need 3 labels here. So let's just do like A, B, and C or something. Okay, so, and that actually should be index equal to that. So this is going to set up our data frame. Note how, again, column is still 0, but we're at least passing in explicit labels to A, B, and C, which are our rows here. Now, look at what will happen if we try to do the same with our columns. So we're basically just replacing the index argument with columns. Well, that's actually not allowed, okay? And the reason this isn't allowed is because we're saying when we do something like this, we're saying there should be 3 rows, okay, but there's no necessary column structure. Whereas that was fine with a scalar value, we could just pass in the rows and columns. Here we need to explicitly pass in at least one data point for each column and for each row, okay? So this isn't allowed. I'm just going to make a note of that actually. But we could do the same if we could do basically just assigning the index. That is totally fine. Also, I should note that we could do something like this. Let's say we wanted to just copy and paste that there. What we could do is, let's say 1, 2, and I'm actually just going to copy this. Okay, and then we could do like 3, 4, 5, and 6. Okay, and then just encompass these in a list. So essentially we have a list of lists here. This structure would imply 2, or rather 3 rows here of 2 columns. Okay, so let's say we want to do this. We need basically a column label for each of the columns. Okay, but we don't necessarily have to add an index label this time. Okay, so that's totally fine as long as you have at least one element for each of the columns that you're specifying. Similarly, we could pass in row labels as well if we want. We could say index is equal to, and then some row labels like, I don't know, let's just say row 1 here. We do row 2. Okay, and we could, we could also do row 3. Okay, so that's fine as long as we have 3 rows and we're specifying the correct structure. Things get, well, we couldn't do, let's say, fewer rows. That's going to give us a problem, nor could we do more rows. We need to make sure that we have the exact number of rows and columns there if we're passing in explicitly structured data. Okay? So that's basically all I want to point out with regards to the lists and the labeling. Now we're going to be focusing more on the actual dictionary. So I'm just going to separate these out with this comment here. So let's say we wanted to create just a pretty simple data frame with an explicitly labeled column. Well, we know we can do something like this, but maybe something a bit more like this. But it would be easier just to create a pandas data frame from a dictionary. So we could just do something like this. It's equal to a pandas data frame, okay? And instead of a list, we're going to pass in a dictionary. So here we pass in the column labels. Let's just say we want our first column to be col1. Okay, and then whatever value we want. Now, in this case, we would probably pass in maybe a list of values. We could do like 1, 2, and 3, and that's totally fine. What this is going to do is it will explicitly assign this label to our column, and it will set this data equal to that column data. Now, one important distinction between this and what we were doing previously is that creating them through dictionaries, creating data frames via dictionaries, fills in the column information. So each of the labels of the dictionary will be the column title, and then the value we assign will be the data in that column. That's kind of different from what we have here, whereas each of the inner array, or rather each of these inner lists, is actually the row data, and then in the inner elements are the column data. Okay, so when we create data frames through a list of lists, that's essentially specifying the row data, or data by row. And when we create them through a dictionary, that's specifying the data by columns, okay? Now, we can pass in multiple columns worth of data as long as it's all within the same dictionary. For example, let's say I wanted a second column, okay? And I wanted this to be like 4, 5, and 6. We should make sure that they're of the same length. So if I try, for example, 4, 5, 6, and 7, that is going to give me an error. And it's basically saying that all of the arrays must be of the same length. Okay, so if you're specifying things by column like this, you need to make sure that we're dealing with the same length of data. Okay, so 4, 5, 6 is allowed, 4, 5, 6, and 7 is not. And actually, you know what, I'm going to make a note of that. This is not allowed, whereas this is totally fine. Also, we can pass in index labels if we want as well. So we could set index labels just equal to, I don't know, like row 1, row 2, and row 3. Okay, but again, make sure that you have the same index labels, the same number of labels there as you have a number of elements in the rows. Okay, so as soon as stuff gets unstructured, then it becomes an issue. As soon as we're trying to mess around with the structure of the data frame, that's where problems are going to start. Now, if I wanted to provide row labels with the data that I'm passing in, I can pass in a dictionary here rather than just a list. For example, let's say I wanted kind of this structure. Okay, what I could do is I'm just going to copy this and paste it for easy reference. Rather than just having 1, 2, and 3 like this in the list, I'm going to create a dictionary and just have like row 1 equal to 1, row 2 equal to 2, that's a 3, and then row 3 equal to 3. And I'm basically just going to copy and paste this into here, and that way I can get rid of the index labels. So for this one, I do need to actually take this and put it inside of a dictionary, okay? And then I'm just going to do 4, 5, and 6, although it doesn't really matter too much what our data is right now. Okay, cool. So essentially what this is doing is we're not passing in a list, we're just saying, okay, I'm going to pass in these index labels for my rows in this column, and then I'm going to pass these in as the values. Okay, so this is kind of the same structure that we got previously. Now, weirdly enough, we can actually do something like this. Let's say I want row 1, 2, and 3, and then I want row 1, 3, and then row 4 here. Okay? Now, that actually works just fine, and it creates another row and fills in the not a number values. Now this is kind of strange that this is allowed, but we can't do something like this, okay? That is not allowed, because when we're passing in a list of values, that is basically setting up the structure and saying that we want this very rigid structure. When we're passing in just the row labels like this, that's a bit more fluid, it's a bit more flexible, and it does allow for this kind of behavior. Essentially the way this will work is it will set up one row per unique label it finds. So in this case we have 1, 2, 3, those are the same, and then the 4. So we have 4 unique labels, 4 rows, and then we'll just fill in any missing values with not on numbers. For example, row 4 has no value in this dictionary, so it fills it in there. Row 2 has no value here, so it fills it in there. Okay, so again, we're seeing that setting things up with a dictionary is column specific. So I'm saying within my column 1, this is the data here, and within column 2, this is the data. Whereas setting things up through list is generally row specific. Okay, now the last thing I wanted to cover is just creating Pandas data frames from Pandas series. That's actually super easy to do. We could just pass in series instead of dictionaries or instead of lists. Okay, so for example, if I wanted to, and in fact, I'm just going to create it on the fly. If I want to create a data frame, okay, and you know what, let's make our jobs a bit easier. We're just going to copy and paste in here, but instead of this stuff, I'm going to have a Pandas series. Okay, and then I'm just going to have 1, 2, and 3. Okay, and then I'll do exactly the same for my column 2, but with maybe some different values. So we'll do like 4, 5, and 6. Okay, so that's totally fine as well. We keep the labels, and this time we're just entering in the same data that we see here. So you couldn't even really tell that we're using Pandas series versus regular lists, and that's because once it's in the data frame, there really isn't any difference. Okay, it just depends on how your data is structured before you pass it into the data frame. Now, one thing that should be noted, if we are actually fetching a whole column's worth of data, that column kind of operates on itself. And so each of those columns is its own Pandas series. So as soon as we pull out a whole column's worth of data, we're now dealing with a Pandas series rather than just like a list of values. All right. So otherwise, I think that is everything that we would want to cover here. We have gone over quite a bit of materials in the last couple sections. And now you know a lot of different tips and tricks about how to create Pandas data frames. So here we started off by talking about using explicit indexes that have different labels from the positional indexes to set up our data frame structure. We also talked about some of the restrictions. For example, you need at least one row of data for each of the columns provided. Okay, and we learned that passing in lists of data is pretty rigid, whereas passing in entire dictionaries of data gives a lot more flexibility. We also covered a couple different kinds of ways in which we can set up Pandas data frames using this column-like structure, and finally how to create them using series. Okay, so as per usual, definitely play around with this stuff until you're super comfortable, you've explored all of the options, and then we can move on to the next section. And that next section is just going to be talking about getting elements from data frames. Okay, so stay tuned for that. Thanks for watching, and see you guys in the next one.